This lecture is on properties of acid-base salts. The emphasis is on determining the expected pH of aqueous salt solutions. Salts are derived from a combination of either a strong or weak acid with a strong or weak base. The different categories of salt solutions could fall under include neutral, acidic, basic, or a hybrid of acidic, basic, or neutral. This table shows examples of each of these categories. Acidic cations include conjugate acids of weak bases like NH4+ and cations of highly charged metal ions including Fe3+ and CO2+ ions. Neutral anions include conjugate bases of strong acids including Cl-, Br-, and I- ions. Neutral cations include counterions of strong bases including Na+, Li+, and K+ ions. Basic anions are derived from weak acids including F- and Cn- ions. Neutral salts have an expected pH of 7. These salts are derived from a strong acid and a strong base. For example, an aqueous solution of sodium chloride dissociates to form sodium and chloride ions. Sodium ion is a non-acidic, non-basic species from a strong base of NaOH, where Cl- ion is a weak conjugate base from a strong acid of HCl. The hydrolysis of each ion is as follows. When sodium ion reacts with water, it appears that sodium hydroxide and hydrogen ions are produced. When chloride ion reacts with water, it appears that hydrochloric acid and hydroxide ions are produced. The problem is that neither of these reactions will occur because the products will react with each other in reforming the original reactants, resulting in no reaction. Basic salts have an expected pH greater than 7. These salts are derived from a weak acid and a strong base. For example, an aqueous solution of sodium fluoride dissociates to form sodium and fluoride ions. Sodium ion is a non-acidic, non-basic species from a strong base of NaOH, where F- ion is a strong conjugate base from a weak acid of HF. The hydrolysis of each ion is as follows. When sodium ion reacts with water, it appears that sodium hydroxide and hydrogen ions are produced. When fluoride ion reacts with water, it appears that hydrofluoric acid and hydroxide ions are produced. The problem is that only the anion hydrolysis will occur because in the cation hydrolysis, the products will react with each other in reforming the original reactants, resulting in no reaction. Acidic salts have an expected pH less than 7. These salts are derived from a strong acid and a weak base. For example, an aqueous solution of ammonium chloride dissociates to form ammonium and chloride ions. Ammonium ion is a strong conjugate acid from a weak base of NH3, where Cl- ion is a weak conjugate base from a strong acid of HCl. The hydrolysis of each ion is as follows. When ammonium ion reacts with water, it appears that ammonia and hydrogen ions are produced. When chloride ion reacts with water, it appears that hydrochloric acid and hydroxide ions are produced. The problem is that only the cation hydrolysis will occur because in the anion hydrolysis, the products will react with each other in reforming the original reactants, resulting in no reaction. Acidic salts have an expected pH less than 7. These salts can also derive from a small, highly charged metal ion and a weak base derived from a strong acid. For example, an aqueous solution of ferric chloride dissociates to form iron 3 and 3 chloride ions. Cl- ion is a weak conjugate base from a strong acid of HCl. The hydrolysis of each ion is as follows. When iron 3 ion, rewritten as hexa-aqua iron 3 ion, with a 3 plus charge reacts with water, it appears that penta-aqua hydroxyl iron 3 with a 2 plus charge and hydronium ion are produced. When chloride reacts with water, it appears that hydrochloric acid and hydroxide ions are produced. The problem is that only the cation hydrolysis will occur because in the anion hydrolysis, the products will react with each other in reforming the original reactants, resulting in no reaction. If you are working with a hybrid salt, these salts are derived from either a salt involving an amphoteric species like an anion, or 2, a salt derived from a weak acid and a weak base. In either case, Ka of the weak acid and Kb of the weak base are needed. For example, an aqueous solution of ammonium acetate dissociates to form ammonium and acetate ions. Ammonium ion is a strong conjugate acid from a weak base of NH3, where acetate ion is a strong conjugate base from a weak acid of acetic acid, or HC2H3O2. If your salt solution falls under this category, you must compare the Ka from cation of the weak base versus Kb from anion of the weak acid. Conclusions: 1. If Ka, cation of the weak base, is greater than Kb, anion of the weak acid, pH will be less than 7. 2. If K, cation of the weak base, is less than Kb, anion of the weak acid, pH will be greater than 7. 3. If Ka, cation of the weak base, is approximately equal to Kb, anion of the weak acid, pH is approximately 7. For example, classify NH4C2H3O2 or ammonium acetate as either an acidic, basic, or neutral salt. For the cation, ammonium ion reacts with water to produce ammonia and hydronium ion. The Ka of ammonium ion equals 5.6 times 10 to the minus 10. For the anion, acetate ion reacts with water to produce acetic acid and hydroxide ion. The Kb of acetate ion equals 5.6 times 10 to the minus 10. Since Ka is approximately equal to Kb, this salt is pH neutral. Lastly, what if you have a salt where the anion is amphoteric, a species that can act as either an acid or base in a reaction? How does one resolve this? For example, if you take sodium bicarbonate and dissociate it in water, sodium and bicarbonate ions are produced. The bicarbonate ion is of interest because to determine the pH of this salt will depend on the relative strength of the ion. Let's look at it in more detail. When sodium ion reacts with water, it appears that sodium hydroxide and hydrogen ions are produced. However, the problem is that for the cation hydrolysis, the products will react in reforming the original reactants, resulting in no reaction. For the anion hydrolysis, bicarbonate can undergo either acid or base hydrolysis. If the bicarbonate acts as a base when it reacts with water, the products are carbonic acid and hydroxide ion. The Kb1 value of bicarbonate ion is 2.3 times 10 to the minus 8. If the bicarbonate ion acts as an acid when it reacts with water, the products are carbonate and hydronium ion. The Ka2 value of bicarbonate ion is 5.6 times 10 to the minus 11. Since the Kb1 value is greater than the Ka2 value, this is a basic salt with a pH greater than 7. To conclude this lecture, here is a review exercise for you to work on. For the following salts, you may need to infer your textbook or provided information, determine if the following aqueous salt solutions are acidic, basic, or neutral. Support your answers by a combination of net ion equations and calculations. Do not provide the actual pH, but the expected pH of the salt solution. They are BaCl2, CuNO2 parentheses is 2, NH4Cn, LiNO3, and NaH2PO4. For the remaining part of this lecture are solutions to exercises or problems. Please view only after completing these exercises.